Hi, I'm Floris and this is
Amelie. We are Lab Group C, Group 2.
And we are here to explain how our Pico works for the Lab 4 assignment. Amelie is gonna explain the hardware setup and then we'll get into the software.
So here we have our 4 LEDs connected to our Pico. Each LED is connected to GPIO pin 1, 2, 3, and 4. And this is, if we look at it, yes, this way. This is bit 1 in our binary counter, and this is bit 4, 1, 2, 3, 4. So we represent binary counting in the correct way. Then here at GPIO 5 and 6, we have our up and down button. And this just increases or decreases the timer. We have our buttons connected to ground, along with resistors, so we don't blow out the LEDs.
And program 1 is currently preloaded on it, so if we press the up button, you can see that the timer increases. The problem is just you have to be really quick, because otherwise you multi-press it, and with the down button we decrease our timer. So this is task 1 working. Now we'll go towards the code. For the code, we have the the definitions here, the up button, the down button, and then the bits. Here we initialize a counter. This is our method for lighting everything up, where we create a temporary array so we can manipulate the numbers. Then if we want to light up bit 1, we take the modulus of 2, so for all odd numbers bit 1 will be on, and we can see that by doing the modular. Here for everything that is bigger than 2, we do the same thing, and it continues to light up all the buttons, all the LEDs. Then we have our button control. This is the method we call using our interrupt. We at first had it set up in 2 different ones, one for the up counter, one for the down counter, but we could not get that to work, so we ended up doing it in one. We have, if the GPIO is the up button and it is triggered with a edge fall, then and the counter is smaller than 15, we increase the counter. If it is not the case, then we check if it is the down button, if the event has happened, and if there is an interrupt. If the counter is larger than 0, we decrease the counter, and then we light everything up again. Here we have the initialization, where we initialize the up button, the down button, the bits. And these are the interrupt setups. The up button GPIO, then the interrupt, we set it to true, and we call button control, and here the same for the down button. Then we light it all up. This is not per se necessary, but I like knowing that it works. And then we loop through our contents, and this gives us a working program. Now we're gonna load task 2 on there.
And before we go to task 2, this extra button here on our breadboard is connected to GPIO pin 0, and is the reset button for our task 2. And here you see that if we press the reset button, it resets the counter. Once again, resets it. So there we have our task 2. Now here for the code, we have fairly the same setup as task 1. Instead of an up and down button, however, we do have a reset button defined there. We initialize our counter. We have the same temporary array to represent the lights on the LEDs. And then here the this establishes that when the button is pressed, the counter is set to 0. Here we have our timer callback. This we got from the lecture and establishes that so we have an if statement. If the counter is less than 15, we increase it and then we light everything up again. And then we call the same function again after 1 second has passed. Here we have the initialization of the reset button. Again, the difference from task 1 is that it's 1 button instead of 2. And our LEDs. Here we have our interrupts. So this is the interrupt setup for the reset button. So this is the button itself. The interrupt, we set the interrupt to true, and this is which method we are calling the button control. Then here we have the timer set up. This starts the initial timer that we do, and it starts 1/10 of a second after the program starts. So this is the 1/10 of a second. This is the method we use. We do not give any user input here, so this is null. And we set it true because we want it to run. Then we loop everything once again like we did in task 1. So we loop and start our program. Thank you.
Thank you.